Hello students, welcome to today's class. In this class, I'm going to revise the chapter 1, that is the real numbers. So the first topic we have studied in this chapter is actually what fundamental theorem of arithmetic. Okay, so this is actually the first topic, fundamental theorem of arithmetic. Theorem of arithmetic. So now let us recall. So what actually it says, fundamental theorem of arithmetic. So it says like this: every composite number can be expressed as a product of primes, and the representation is unique apart from the order of the prime factors. Let us take an example of a number. So first let us understand what are prime numbers. Prime numbers are always starts from what 2 actually. Okay, 1 is not a prime number. Remember, 2, 3, 5, 7, 11. Okay, and then 13 and so on. So these are actually called as what prime numbers. Now how to what actually it says, if you take any composite number, it should be a composite, means other than prime number. I'm going to consider a number like this 156. Okay, so what type of number it is? It is actually what composite number. So actually, according to this theorem, okay, fundamental theorem of arithmetic, you can express this composite number as a product of prime numbers only, and the representation is unique apart from the order of the numbers. Okay, order of the prime factors. So it is obviously unique way. Okay, so now let us see how can we express 156 as a product of prime numbers. Now let us look at here 156. First I'm going to divide this one by a number. Okay, it should be a prime number only. You need to divide this number only by what? Prime numbers. Okay, means it should be a factor. So definitely it is divisible by 2. So that's why 2 sevens are 2 8s are 16, and again it is divisible by 2. Okay, it should be prime number. Okay, whatever you are going to write on here, it should be prime number. 2 3s are 6, 2 9s are 18. Okay, so now it is not divisible by actually what? 2. So now it is actually divisible by which number? 3. You need to move on to the next number, second number. Okay, so 3 ones are 3 and 3 threes are 9, and 13 is actually what type of number? It is a prime number, so that's why I'm not going to continue this one. So now you can write on like this: 156 is equal to you 2 into 2 into 3 into 13. If you take the product of these prime numbers, and it should be equal to 156 actually. Now look at here, it will become 2 into 2 into 3 into 13 actually. So or else you can write on 156 is equal to 2 into 2, 2 square into 3 into 13. Okay, if you take the multiplication of all these numbers, you will get 156. This is actually the fundamental theorem of arithmetic. If you take any composite number, okay, it can be always expressible in this form, so that it is a multiplication of prime factors, and this representation is unique. Okay, you can't express 156 in another format apart from the order of these numbers. Okay, but if you write on like this, 156 is equal to 13 into 3 into 2 power 2, so it is not a different format. Okay, so the same thing, but here the numbers are actually arrangement is different, just like that. Okay, so this is actually apart from the order of the prime factors. So now this is actually the way of representing a composite number as a product of prime factors. Remember, all these must be what? Prime numbers. So now the second thing is Hcf and Lcm by fundamental theorem of arithmetic. Actually, we are going to study fundamental theorem of arithmetic to find out Hcf and Lcm of two or more numbers. Okay, you can find out Hcf and Lcm for two numbers or two or more numbers. So in this chapter, we have studied the finding of Hcf and Lcm of two numbers or three numbers actually. Now I will show an example for you just for two numbers. The same will be carried for three numbers also. Now I'm going to choose two numbers. Let us take like this: a is equal to 72 and b is equal to 120. Now I have to find out LCM of these two numbers. Okay, and then also HCF of these two numbers. First I'm going to find out HCF and then LCM. So before this, you need to factorize this one. According to the fundamental theorem of arithmetic, a and b are actually what type of numbers? Composite numbers. Always composite numbers will be given to you, and you need to factorize these two numbers. If you factorize 72, you will get like this. So first I'm going to divide by 2. 2 3s are 6, 2 6 are 12, and then again by 2. 2 1s are 2, 2 8s are 16, and again by 2. 2 9s are 18, and then again by 3, 3 threes. Okay, so then I'm going to stop here, and then after that 120, if you divide this one by 2, initially 2 6 are zeros, and then again 2 threes are, and then zeros, and again 2 15s are. Now it is divisible by 3, actually 3 5s. So that's why 72 can be written as what? So now look at here. So 2 2 2, it appears how many times? 3 times. So 2 4 3 into here 3 3 appears 2 times, 3 4 2, and then 120 means 120 is equal to what? 2 2 2, it appears 3 times, 2 4 3 into here 3 power 1 into 5 power 1, actually. Okay, even you, if you don't write on 1, it is understood for you. 1 is present, exponent is actually what? 1. Okay, so now the next thing is I want to find out what HCF and LCM of these two numbers. So what actually it says HCF of A comma B. So I have given the formula for you. You need to identify only what common factors. Okay, common factors. So in the prime factorization of 72 and 120, what are the common factors? 2 is the common. Okay, 2 is common, and 3 is also common, but 5 is present here, it is absent. So that's why I'm not going to consider this one as a 5 as a common factor. Only common factors are actually what? 2 and 3. You need to write on those numbers 2 and 3. What will be the exponent? Exponent should be least. I told for you, it should be opposite to that of this one, that is highest, means you need to consider lowest power, actually. Okay, so lowest power of 2 is actually what? 2 power 3, 2 power 3, same exponent is there. So that's why you need to carry the same exponent. Suppose here it is 3, suppose it is 2, then you need to write on what? Exponent 2. But here exponent is same in the prime factorization of both numbers. That's why you need to carry the same exponent. And the next thing is here 3 is present, 3 power 2, and then 3 power 1 is present. What is the least exponent among these two? 2 and 1. So 1 is the least exponent. That's why I'm going to carry 1. So now 2 cube means how much? 8 into 3. 8 into 3 is equal to 24. So that's why the HCF of these two numbers is equal to how much? 24. In the same sense, I am going to find out what LCM now. Okay, LCM of A comma B, which is equal to. So now LCM means here the first letter is L. Opposite to the top is what? Highest. Okay, you need to consider what? Highest power. Highest power, but not for common factor, but it should be for all factors. Okay, so don't consider here only the common factors. It is only for what? HCF. But for LCM, you need to consider all the factors. So what are the different factors present here? 2, 3, 1, then 5. Okay, 2 3 5 or the different factors. I'm going to write on 2 into 3 into 5. Okay, so now exponent, highest exponent you need to write on. Okay, what is the highest exponent of 2? 2. Okay, here same is present means you need to write on the same thing. But here 3 power 2, 3 power 1, what is the highest exponent among these two? 2. That's why I'm going to write on 2. But 5 power 1, but 5 is absent here, but you need to write on the same thing. So that's why it will become 5 over 1. So now 2 cube means 8, and then 3 square means 9, and then 5. So then 9 8s are 72, and then into 5, and then 5 2s are 10, 1 carry, 5 7 are 35, plus 1 36, 360. So that's why LCM will become how much? 360. So this is the way to calculate HCF and LCM by using what? Fundamental theorem of arithmetic. So just remember the thing while calculating HCF. Okay, while evaluating HCF, you need to write on only common factors. Just remember this one, common factors. Okay, so when you are going to evaluate LCM, okay, when you are going to evaluate LCM, you have to write on all possible factors, all the factors with the highest power. Remember, with highest power. But while writing the common factors, you need to write on what? Least power. Remember, you need to write on the least power of these two. Then you will get what? HCF and LCM of the given two numbers. The same the same procedure will be extended for three numbers also, and I have solved some questions for you, and you can look at the problems. So one more important thing is a relation between HCF and LCM of A and B. So I told for you, so the relation is actually like this: HCF of A comma B into LCM of A comma B is equal to what? A into B, means product of two numbers. This is actually very important. So when two numbers are given to you, and also for three numbers I have given for you, but it may not be asked in the examination. That's why this actually seems to be very important. Just look at, concentrate about this one. Okay, HCF of A into B into LCM of A into B is equal to what? Product of two numbers. Remember this one. So if he wanted to ask problems on this concept, he may ask like this. Okay, so find HCF and LCM of A comma B, HCF of A comma B and LCM of A comma B, and also verify the relationship between HCF and LCM. Then you need to show like this. Okay, you need to take the product of HCF and then LCM, and after that you need to calculate A into B also. These answers should be equal. Okay, then the relation will be verified. Okay, so always the relation is true for any numbers A and B. Remember this one. And sometimes he may give the problem like this. Okay, here how many variables are there? Look at here, HCF into LCM is equal to A into B. Okay, sometimes he will give the HCF and he will give HCF LCM and he will give A, and he will be asked to find out what is the value of B, like this. But sometimes he will give this one LCM and he will give A and also B, and he will be asked to find out what is the HCF. Okay, what is the HCF? Without factorization you need to answer this one. Okay, so if LCM is known, you can immediately calculate what is the HCF. How can you calculate? How to calculate HCF? You can do like this: A into B divided by LCM. You will get what? HCF. And if LCM is known for you, let us if LCM is known, you can find out HCF by using this relation. And also in the same sense, if HCF is known, you can find out LCM. LCM is equal to what? A into B divided by HCF. Okay, if HCF is known and A and B are also known, then A into B divided by HCF gives what? LCM. So this is actually the advantage of relation, and I have solved some questions about this one. Okay, you can go through that one. You can understand what is the relation and how the problems will be asked about this relation. Next topic is actually revisiting irrational numbers. Actually, I think you know what are irrational numbers. Numbers which cannot be represented, which cannot be represented represented in the form of in the form of P by Q, actually. Okay, in the form of P by Q. So if it is not possible, actually what P comma Q are actually what integers, and the Q should not be equal to 0. If it is not possible, okay, if it is difficult to express a number in this form, then the number is actually called as what? Irrational number. So now in this chapter, actually we are going to prove the irrationality of some numbers. Okay, the best example is actually what? Square root of 2, square root of 3, square root of 5, and so on. And I told for you square root of a prime number. If you write down a prime number within the square root, it is always what? Irrational number, actually. Okay, so these are all the same thing. Okay, 2 is prime, 3 is prime, 5 is prime. So that's why these are all actually what? Irrational numbers. Okay, square root of a prime number is always irrational number. So now in this chapter we are going to prove the irrationality of these numbers. Okay, like this: root 3, root 2, root 5, like this. This is actually the first type of problems, and the second type is he may ask a number which is in the form of what? Let us take 2 plus root 3. It is a combination of what? This is a rational number, this is irrational number. Okay, this is rational, irrational, and I have given the table for you. Rational, okay, plus irrational is always irrational. Okay, remember. And then rational minus irrational is also irrational. Okay, and also rational divided by irrational, or irrational divided by rational, it is also actually what? The result is always irrational. So except this should not be equal to 0. Okay, whenever, but it is always equal to what? Non-zero number, irrational. So this is actually always an irrational, because irrational number means 0 is not an irrational. That's why there is no need to say here irrational should not be equal to 0, like that. But in rational numbers only 0 is included in rational. That's why I told for you. In the same sense for multiplication also. Okay, now look at here: rational into irrational or irrational into rational. this is always equal to what result? Irrational number, except don't put this one equal to 0. Okay, this should not be equal to 0. Here also this should not be equal to 0, because if it becomes 0, 0 into something is always 0. You will get finally 0. 0 is actually what type of number? Rational number. That's why while multiplication and division, you need to consider what? Non-zero rational. Okay, non-zero rational. But while adding or subtraction, you may consider 0 also. Even if you consider 0 in this place, the result is once again what? Irrational number. We are going to prove the irrationality of this type of numbers and the irrationality of these type of numbers. Okay, addition, multiplication, subtraction of and division of two numbers. Among those, one is rational and another one is irrational, like that. Actually, initially I have solved the problems like this. Prove that root 2 is irrational, root 3, root 5, like that. Okay, just look at here how to prove this one. Simply I'm going to follow the steps. Okay, important steps. So root 2 is equal to, you need to take like this. Okay, initially it is a of the form p by q. By the contradiction method, I'm going to initially assume root 2 is actually what type of number? It is not an irrational, it is a rational. Okay, contradiction. I'm going to take the reverse of the given statement. I'm going to assume it is a rational number. So it is a rational means you can write on that number in the form of p by q, where p and q are actually what? Integers, and q not equal to 0. Okay, and both p and q are actually what? Very important thing is p comma q or co-prime. Okay, co-prime means what? P and q, okay, p and q doesn't have divisors other than 1 and itself. Okay, so for p only 1 and p are the divisors. For q also 1 and q are the divisors. Okay, there will be no common divisor. Okay, for both p and q. Okay, just take like this. For both p and q, the common divisors are actually what? 1 is the common divisor. There will be no number which is greater than 1. So then those numbers are actually called as what? Co-prime or relatively prime. Okay, remember both are one and the same. So now I'm going to square this one. If you square this one, you will get like this. 2 is equal to p square by q square. Now I'm going to shift this one. 2q square is equal to p square, or else you can write on like this. P square is equal to 2q square. So now look at here how it look like actually. So you can, if you write on p square is equal to 2 into q square, it shows that 2 divides p square. Okay, this is actually the symbol of division. Actually, if you don't know this one, you can write on 2 divides p square. 2 divides p square. 2 divides p square. Okay, so then by one of the theorem we can say actually what? 2 divides p also. Okay, by the previous theorem. Okay, if 2 is a prime number and it 2 is a prime number, and if divides a p square, then it is also divides p also. Okay, this is actually by the theorem. Actually, in the same sense, you can also show like this. If 2 divides p, I'm going to write on like this. 2 is equal to, if 2 divides a p, you can write on p is equal to 2 into some number. You can take any number. I'm going to consider a c actually. Okay, now I'm going to make a square this one. P square is equal to 2c whole square. Then this will become 2 square 4, and then c square, like this. Okay, so this implies, now I'm going to replace p square by, look at here, 2q square. Okay, if you replace this one by 2q square is equal to 4c square, this implies, so now 2 ones are and then 2 2s are here, it will become what? Q square is equal to 2c square. By this we can say what? 2 divides q square. Okay, so now I'm going to write on here 2 divides q square. Okay, so now look at it. 2 divides q square means 2 also divides q also. 2 also divides q by theorem. This is actually what? By the theorem. Okay, so now 2 divides q, 2 divides p. So that's why 2 is actually what? Common divisor for, common divisor for both p and q. But this is actually contradiction to our fact that both the p and q have the common divisor 1. Okay, the only common divisor of p and q is 1. This is because p and q are actually what? Co-prime. but here it is actually like this. Okay, we arrive finally at P and Q have a common factor which is other than 1 also, it is 2, but this is actually contradiction. This contradiction arises because of our wrong assumption in the first step that root 2 is a rational number. So therefore finally I'm going to write down our assumption is wrong. So finally we need to write down root 2 is irrational number. Okay, so this is the way how to prove the irrationality of a number when it is given like this: root 2, root 3, root 5. Prove these numbers are irrational like that. So if this type of problems are asked for you, so I told for you one will be rational and another will be irrational number. They will be added or subtracted, or they will be multiplied, or they will be divided also. So if this type of problem is asked, procedure is very simple. Okay, don't follow the previous procedure. You need to follow the previous procedure only when these irrationality of these type of numbers are asked to do for you. Okay, root 2, root 3, root 5, root p. Okay, he may ask root 7 also, and then root 11 like this. Okay, if this irrationality of this type of numbers, if you want to prove the irrationality of these type of numbers, then only you need to follow the previous procedure. So otherwise, if the numbers is like this, okay, addition, subtraction, multiplication, division of one is rational and one is irrational, you need to follow this step. Initially the same thing, contradiction method. Initially I'm going to assume our 2 minus root 3 is a rational number, so that's why I'm going to put this one as a 2 minus root 3 is equal to a, where a is actually what, some rational number. Okay, a is actually some rational number. Okay, a is rational, remember. So now I'm going to express this one like this. Okay, so I want to express this one as irrational number is equal to something. Okay, like this. Okay, so in this one, root 3 is actually irrational. It will be given to you in the problem itself, where root 3 is irrational. It will be given in the problem itself. Even though it is not given to you, even you can consider this one because it is already known for you. Root 3 is already an irrational number. So that's why my intention is to separate this root 3 towards one side and the remaining numbers towards one side. Now look at it, it is negative. That's why I'm going to shift this number towards the right side and a towards the left side. It will become 2 minus a is equal to root 3, or else you can write on 2 root 3 is equal to 2 minus a. Okay, so in the left hand side, what type of number this is? It's actually what? Irrational number. And if you look at the right side, now look at here, 2 is what type of number? Rational. You know this one. Okay, 2 is a rational number because it can be written in the form of p by q, 2 by 1. Okay, that's why it is a rational. And a is also what type of number? Rational. Look at here, a is rational. Rational minus rational is always rational. Remember, rational plus rational is equal to rational. Rational minus rational is equal to rational. Rational into rational is equal to rational. Rational divided by rational is always rational, provided it should not be equal to 0. Remember. Okay, so now this will again become rational minus rational. Rational minus rational is again what? Rational. Okay, so now here it is rational number, here it is irrational number. Is it possible to say a rational number is equal to irrational number? No, definitely it is not possible, because rational and irrational numbers, they are actually different. Okay, so rational numbers are different, irrational are different. There is no number which is both rational and irrational at a time. So that's why this is actually wrong. So this wrong condition or wrong statement or wrong result arrives because of our wrong assumption that root 2 minus root 3 is a rational number. Okay, so that's why our assumption is wrong. Finally you need to write down what, therefore 2 minus root 3 is irrational. Okay, so this is the simplest way to prove this one. Okay, so I think this is the better way. And if the problem is asked like this, then you need to follow the procedure like this. Okay, for if the problem is like this, then the procedure is different. Okay, so that's why there are only two types of problems under this heading, revisiting of irrational numbers. Okay, so concentrate more about these problems, because they are very important for the point of examination. So the last topic of this chapter is actually decimal expansion of rational numbers. So now I think you know what are rational numbers. Rational numbers are actually in the format of p by q. Okay, but you can express this number which is in the form of p by q to decimal format also. Okay, decimal format. Okay, so what will be the decimal format of a rational number? So there are two possibilities. Okay, so one is it may be terminating. Okay, remember, one possibility is terminating, and one more possibility is It is non-terminating but recurring. Okay, recurring. Okay, I will give an example for you. Terminating means just if I consider 1.24, okay, it is a terminating. But if I consider the number like this, okay, 1.737373 and so on, so this is non-terminating but recurring. Recurring means a sustained string of digit goes on repetition. Okay, here the repeating string contain how many numbers, how many digits? 2 digits. Okay, if I consider 0.3333 and so on, okay, here 3 goes on repetition. Repeating string contain only 1 digit. In the same sense, I'm going to consider 7.320320 and so on like this. Okay, so now this is also a number which contains the repeating string contains how many digits? 3 digits. Here only 1 digit, here 2 digit, like this. Okay, this is called as actually what? Recurring, and it should be actually what? Non-terminating, but here it is terminating. When you express a rational number which is in the form of p by q format to decimal format, two possibilities are there. One is